In this video, we're going to look at the rules that we use to prove that two objects are similar. So there are 4 rules that we use to work out whether two objects are similar. Now these rules you may think are similar to the rules for congruency, and yes, they are similar, but they're not exactly the same. So you need to look at these rules and learn how to use these rules independent of the rules for congruency. And the 4 rules are angle, 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 which we use this abbreviation of 3 A's, side, 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 where we use the abbreviation of 3 S's, side, angle, side, where we use the abbreviation of SAS, and the last one is right angle hypotenuse side, and we use the abbreviation of RHS. Now we'll have a look at each of those individually and see when we can apply them. So the first one we're going to have a look at is angle, 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 or the abbreviation AAA. And we can use this rule when we have 3 angles within a triangle that are the same. So we can see that we've got an 80 degree and an 80 degree, a 70 degree and a 70 degree, and a 30 degree and a 30 degree. So we have 3 sets of matching angles that are all the same. So we can say that those 2 objects are going to be similar because they all have corresponding angles that are equal in size. It's important to remember that when we're dealing with triangles, all of our angles in a triangle add up to 180 degrees. So if I've got 2 sides that are the same, but I don't know what the third side is, I can still use the angle, angle, angle rule because I know that the third angle is going to have to equal the same in both triangles because the other 2 angles do. So I can use angle, 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 even if I only know they've got 2 corresponding angles that are the same. I don't need to know all 3, but if you're writing a proof and you're using angle, 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 and you can prove all 3, please use all 3 in your proof. And the second rule we're going to have a look at is side, side, side with the abbreviation of 3 S's. We can use this rule when we have 3 sets of corresponding sides that have the same scale factor. So to be able to use this rule, we need to be able to calculate the scale factor of all 3 sides. So before we do that, we need to identify the corresponding sides in both of the objects. Now with triangles, the easiest way to do that is to look for the largest side on the first triangle and the largest side on the second triangle, and they are going to be corresponding. Then look for your smallest side on the first triangle and the smallest side on the second triangle, and they are going to be corresponding. And then the middle side that we have left on the 2 triangles will be our third corresponding side. So now that I know what sides are corresponding, I can go ahead and calculate my scale factors. So scale factor for my longest sides is going to be 6 divided by 5, which is equal to 1.2. On my smallest sides, the scale factor is going to be 4.8 divided by 4, which is equal to 1.2. Now it's important to remember, because I used the side on the second triangle for my numerator in my first scale factor calculation, I need to always use that second triangle first for the numerator when doing my scale factor calculations. So that's why I use 4.8 as my numerator in the second scale factor calculation. And for the third one, again using the second triangle as my numerator, 5.4 divided by 4.5, which equals to 1.2. So because all 3 sides have the same scale factor, I can say that those 2 triangles are going to be similar using the rule side, side, side. Right, the third rule that we're going to have a look at is side, angle, side, which uses the abbreviation SAS. Now to be able to use this rule, we need to have 2 sides that have the same scale factor. and then those two sides being separated by the same angle. So to be able to use this rule, we need to be able to identify two corresponding sides. So I can identify 4.5 because that is my largest side on the first triangle, and 3 because that's the largest side on my second triangle, and those two sides are corresponding. Then I can also identify side BA and side ED as my second set of corresponding sides. So now that I know my two sets of corresponding sides, first I need to check the scale factor. So scale factor, and this time I'm going to use the first object as my numerator. So it's going to be 4.5 divided by 3, which is equal to 1.5. And then doing the same calculation for my second set of corresponding sides. So scale factor is going to equal 1.5, using my first object again for my numerator, divided by 1 is equal to 1.5. So I've got two sets of corresponding sides that have the same scale factor. Now I need to make sure that I've got an angle, the same angle between them. So between AB and BC is angle 130, and between DE and EF is 130. So I've got the same size angle between my two sets of corresponding sides that have the same scale factor. So I can use the side angle side rule to prove that those two triangles are going to be similar. The last rule that we're going to have a look at is the right angle hypotenuse side rule, which is abbreviated to RHS. Now to use this rule, we need to start off by having two right angle triangles. So we can see in our example that we have two right angle triangles. Then to be able to use the rule on the right angle triangles, we need to have the hypotenuse and then one other pair of corresponding sides having the same scale factor. So the hypotenuse is going to be the side that is opposite the right angle on both of my triangles. So my hypotenuse is going to be AC and FD. And I can calculate the scale factor on that. So scale factor is going to equal 10 divided by 5, which equals to 2. So now that I know I've got a hypotenuse with a scale factor of 2, I need to check the scale factor of one other set of corresponding sides on my triangle. And the other set of corresponding sides is AB and ED. So I need to use those two sides to calculate the scale factor to see whether it's the same as my hypotenuse scale factor, which in this example is 2. So scale factor is equal to 8 divided by 4. And because I used the second triangle as my numerator when calculating the hypotenuse scale factor, I need to do the same thing when calculating the side scale factor. So 8 divided by 4 is equal to 2. So I can now show that I've got a hypotenuse and a side with a scale factor of 2, and it's a right angle triangle. So I can use the right angle hypotenuse side rule to prove that those two triangles are going to be similar.